guys, sorry to interrupt your video. Just a quick plea, subscribe to my channel please. If you haven't done it already, subscribe. Tell your friends, subscribe. Thanks. Hi guys, back we go again. Right, this time for the exhaust system. Really common question that comes up on the theory test is about a catalytic converter and where is it and what does it do and all that sort of stuff. So I've subscribed to Engineering Explained on YouTube. Now this bloke here, he's done loads of videos and he's really good at what he does. Probably over technical. A lot of his videos I've just lose the will to live before I'm halfway through them. But he's made some quick ones on this, which I think basically gets the point across. So if it is going over your head, don't worry, just go with the gist of it.
Hello everyone and welcome to this week's video. Today I'm going to be explaining exhaust systems. Now I previously made a video on how to increase horsepower with your exhaust, and it was brought up to me that I hadn't really explained the basics of exhaust, so that's what this video is for. I'm going to explain the basics. And then there's some other things that I'll say at the end as far as different things about exhaust systems that you want to look into. So the very basics of exhaust, of course, it's the last stroke in a 4-stroke engine pushing out those exhaust gases, and you need them to leave, and not only that, you kind of want to clean them up, and you don't want it to be really loud. People don't typically enjoy that. So what we've got here is, here's your little engine block, a 4-cylinder, and you've got your exhaust manifold. So at the exhaust stroke, it's going to be pushing the gases through these different plenums here in this exhaust manifold. So several stages along the way. First up, we've got an O2 sensor, and that's going to be checking the air-fuel ratio. So if your engine is burning too rich or too lean, that's what this is here to kind of fix for you. So if it sees that there's oxygen still in the exhaust, then it knows that you're burning kind of lean, not using all of the fuel that you need, or not injecting enough fuel, so then your engine management system will inject more fuel. And vice versa, if it sees that there's no oxygen, then it'll say, hey, back off on the fuel injection. Next up, we've got a catalytic converter, and the point of this is to reduce harmful emissions, so things like nitrogen oxides, carbon monoxide, and the vaporized fuel, the hydrocarbons, that you haven't burned, assuming it's rich or something like that. So then we've got another O2 sensor after our catalytic converter, and there could be multiple catalytic converters along the way, making sure to clean everything up. We've got another O2 sensor, and this is basically checking the efficiency of this catalytic converter. And that'll make more sense once you watch my video on catalytic converters. I'll have that in the coming weeks. Next up is a resonator. Now, not all vehicles have a resonator. Basically, these are used to drown out kind of specific RPM ranges, kind of like cruise speeds. You don't want to just be on the highway with this really loud noise. And so what this does is you've got your wavelengths of sound coming in here, and that'll break it up. And as they bounce back, they'll bounce back and cancel each other out for specific ranges. And then finally, we've got our muffler. This just reduces noise across the board, reduces pretty much all frequencies, makes it a little quieter so your car's not so loud. And then it all goes out the tailpipe. So that's the basics of an exhaust. I'm going to have a video on O2 sensors, catalytic converters, and mufflers, so we can get a little more in depth into those. And I'll also show a clip real quick just of my car and some of the exhaust parts. So it's kind of hard to see. We've got this heat shield here, which is covering the exhaust manifold, which then goes down underneath the car. And so you can follow that back. And there you've got the catalytic converter, and then that's just going to go back all the way to the muffler. And so here, of course, we have the muffler and then the tailpipe.
Okay, so that's that bit. So he's now done where it all is, the exhaust system. If you're really interested and you haven't lost the will to live, I'll now show you the catalytic converter. Same bloke, explaining how these things work. The long and short of it is it takes horrible gases from the engine in, does some goes through a catalyst, which is hence catalytic converter, and it converts bad gases into not so bad gases as it comes out the exhaust pipes. It's a way of cleaning pollution. That's basically what it does, and now we know it's about halfway down the exhaust pipe. but just in case you were interested, I will show it. But again, it's still engineering explained, still same bloke. This time it's catalytic converters explained. Hope you don't lose the will to live.
Hello everyone, and welcome to this week's video. Today I'm going to be talking about catalytic converters, more specifically three-way catalytic converters. And what three-way means is it's trying to eliminate nitrogen oxide emissions, carbon monoxide emissions, and hydrocarbon emissions, or in other words, unburnt fuels. So the way it does this, inside of a catalytic converter, you've got these two blocks, and one is a reduction catalyst and the other is an oxidation catalyst. And the reduction catalyst is made up of platinum and rhodium, and the oxidation catalyst is made up of platinum and palladium. So what happens is, you've got, from combustion, you've got CO2, you've got carbon monoxide, you've got nitrogen oxides, you've got oxygen, water, and unburnt fuel, all coming into this catalytic converter. Now the first step it goes through is this reduction catalyst, platinum and rhodium, and what happens is you're trying to eliminate the nitrogen oxides. So the nitrogen oxides will come into this catalyst, and so inside of this it's just a bunch of tiny little ducts, little micro ducts, and there's thousands of them, and that's what the air is passing through, so you're trying to maximize surface area with that design. So the nitrogen oxides will come in, and the nitrogen bond with the oxygen isn't as strong as its bond with the catalyst, so it wants to bond with the catalyst. So it'll bond with the catalyst, and when it does that, it'll weaken its bond with the two oxygens. So the two oxygens will separate off, and they may go off, or they can join together. But eventually these two oxygens are going to find another oxygen to pair up with, so that they're O2 rather than just O, which is a little more stable. So once these nitrogens are all alone here on this catalyst, they'll move along the surface. They want to meet up with another nitrogen. That they prefer that bond rather than the catalyst. So once they bond with another nitrogen, their bond with the catalyst is weakened, and they split off and go off to the next step. And so then you're just left with nitrogen and oxygen, which are both perfectly harmless gases, and your catalyst, the surface, is ready to continue this function with other elements and other molecules. So then after you've gone through the first step, we've eliminated NO2 and NO, and so now we just have N2, O2, CO, CO2, H2O, and our hydrocarbons. So the next step is this oxidation catalyst, which is made of platinum and palladium. So what happens in here is the catalyst surface wants to bond with oxygens. So what will happen is the carbon monoxide and the oxygen molecules will come and they'll bond with the surface. Now once the oxygen molecules bond with this surface, they'll split up. And when they split up, the bond with the carbon monoxide is stronger than just by themselves. So they'll bond to the carbon monoxide, they'll form carbon dioxide, and then the bond with the catalyst is weakened, so this will go off and out the catalytic converter, continue on through the exhaust, and then your catalyst surface once again is free and ready to continue doing this function here to eliminate carbon monoxide. So then also within this, you're trying to get rid of these hydrocarbons. And so when we have these freed up oxygens and we've got hydrocarbons, if you haven't watched my video on air-fuel ratio, stoichiometric air-fuel ratio, that may help. Basically, your hydrocarbons and your oxygen are going to form H2O and CO2. They're going to combust within this, react within this catalytic converter, and so they'll be forming the harmless H2O and then the kind of harmful CO2. So catalytic converters do not eliminate CO2, but they do eliminate the other gases, NO2, NO, and CO. So after it's gone through this phase, then you're just left with N2, O2, CO2, and H2O. And catalytic converters can do this on about a 90% efficient basis. So there's still going to be some of these harmful gases left over, but about 90% of them it can convert, and some obviously are better than others. And catalytic converters, one thing to note is they work best once heated up. That's how the reactions occur a little more easily. So that's catalytic converters and their function. If you haven't already, I would recommend watching my video on exhaust systems. It kind of gives you the basic overview. Thanks for watching.
So that's your catalytic converter inside your exhaust system. You now know exactly where it is and what it does. So now you can answer the question on the theory test. Cheers, my dears. Hope that helps.